Okay, so this is a topic number 2 on week 8, and this question is about cis and trans isomer. And cis and trans isomer has something to do with chemical carbon-carbon double bond, and because of this nature, you have this trigonal planar structures. So this attachment around the double bond has on the same plane. And then you are going to essentially put a little dividing line between this carbon-carbon bond and trying to see if they are on the same. We're going to compare this one versus that and find out which one has a higher priority, higher number atomic numbers, or bigger in terms of carbon numbers, and you're going to see which one has a higher priority. And this is the one that I put in a circle. Okay? And if this one on the other side, and if both are pointing in the same upside, and that will be we call cis. Okay? And if the carbon and carbon double bond, and then this the one that divided up the double bond on the base on here, this higher priority, this one is up, and then if this one has the opposite side, and that's what we call trans. Okay, you might see the trans fat in the food label, and the trans fat means there's a fat has a double bond, and double bond has a backbone of a carbons on the opposite side. So it's called a trans fat, whereas a cis fat is more like point in the same direction. So that's where those nomenclature coming from. Okay, and the reason is because when you have a carbon-carbon double bond, they cannot rotate. It is a fix, so it is almost like you are having things on the same plane, and that you can compare. This rotation is not allowed because it's a double bond. Okay, double bond. You remember that the last week we talked about as a pi-pi conjugation, pi-pi double bond. So it has a pretty much the rigid. It's not rotate. I cannot rotate those two. Okay, so let's look at the first compound, and then this is a CH2 double bond. So what I can do, I will always like to draw this one, carbon and carbon double bond first, and here, right, these two carbons are connected by two H's. So this is where I put it in, and the other one is H and Br. And now look at put a dotted line here, and I don't, this and that has the same priority, so this is no cis trans possible, right? So therefore this is a no cis trans isomers possible. So this is a case. When you look at the second one, let's have a careful look at this, the way that how look at the structure. So there's a double bond, and this is connected by this carbon, and this is connected by this carbon. This carbon is connected by methyl and the hydrogen, and this carbon is attached by hydrogen and an ethyl. So this is just the way that people write it as, okay, carbon here is attached by this and that, and carbon attached by here is this and that, right? So, okay, so this is very messy, so I'm gonna clean them up a little bit so that you guys can see what this looks like. And then let me write it once more. So it's good to build a habit of carbon-carbon double bond first, and you can put hydrogen here, you can put methyl here, right? Yeah, okay. You can put either way, you just put somewhere. And this is an H here, and this is a CH2CH3. So that's the one option. And always think about this as a kind of piece of paper shown up here. And I'm going to draw the same thing, but this is time I'm going to use a different one, which is a carbon-carbon double bond, This is an H, and this is a CH3. This time I'm going to put this one CH2, CH3, and this one right here. And some of you might wonder if you can actually flip this papers on the other side. You can see that this one now methyl is pointing up, and then this one, the ethyl, CH2, CH3, pointing down, and H and H. So this, when you flip this, it is the same compound. So we don't distinguish, we don't say the one shown up here is different from the one that's shown on the other side. So this is not being counted as a different isomers. Only two distinct isomers are shown up here. And then now I'm going to looking at the priority wise. I'm going to put a dotted line. Okay, so this one has a higher atomic mass connected to the carbon. If you remember that this is sp2 hybridization, right? These are both sp2 hybridization. And then now if you look at the other right hand side, this is a higher priority over hydrogen. So same side, so it means cis isomer. And whereas this one is in the opposite, if you look at the double dotted line, left and the right priority comparison, this is a trans. Okay, so does here. So let's look at that. Carbon and carbon. Now you are going to put this way, and then bromine and the methyl, and then hydrogen and the chlorine. This is how I'm going to write. And then now you can see that from here, bromine is a high atomic number compared to cis, the carbon, and this is chlorine. Right? So this will be a higher. So in this case, you are in the opposite side, so that's what we call the trans. And as you can see now, you can draw the same thing. Now I can keep bromine and methyl here, and now I can put the chlorine pointing in the same upward direction, and then hydrogen pointing down. And in this case, as you can see, bromine, hydrogen. So this is a cis isomers. Okay, so these are the two examples of cis and trans isomers. That is distinctly different. And no matter how you write on the different configuration, you fall either to opposite side and the same side configuration. Once more, sorry if this is a redundant, but okay, if you write it this way, this compound you find that is identical to the other one, because just simply because this is on the same plane. Trying to write this one and flip this paper upside down and looking through it, and you find that it is the same one. So it's just this is a flip version, so it is not distinct. Okay, so I'm not going to consider that. So this is a cis and this is a trans. Thank you for your attention.